Rah! Hey everybody, how's it going out there? Hey! It's your old buddy Noodle here, and today we're going to talk about multiplying and dividing fractions. Now, if you've been following along with the series, you'll know that we've covered adding, subtracting fractions that have the same denominator and with different denominators, right? But the good news is that when we're multiplying and dividing fractions, we don't have to match the denominators at all. And it's pretty easy. We'll see. Let's give it a try. Suppose we start with a simple case of multiplying fractions. Let's say we have 1/2 times 1/3. What do we do? Not too hard. 1 times 1 is 1. 2 times 3 is 6. And we're done. See? We multiply straight across the numerator and straight across the denominator. It doesn't matter what the numerators or denominators are, just as long as we multiply straight across. 2/7 times 5/10. 2 times 5 is 10. 7 times 11 is 77. Right? We can reduce them if we need to. This one you can't reduce. So first I want to show you what really happens when we do that. Let's look at this first example here. 1/2 times 1/3. When we think about multiplying, usually when we multiply by a whole number, we make the thing bigger. Right? We said that is 1/6. But in the case of a fraction, we're not multiplying 1/2 by 1, right? So we're not going to get 1/2. We're multiplying it by something less than 1. So we're going to end up with less than 1/2. See? Let's look and see what it looks like graphically. I start with 1/2. So here's half of something. And then I take 1/3 of it. What does that mean? I'm going to take our half. I'm going to divide it into thirds. And how many do I want? I want one of those. So now I have 1/3. So you can see I'm left with 1/6 of the whole thing. That's why my answer is 1/6. Right? This is 1/3 of 1/2. It will work with anything. Let's try another case where we have something like, let's look at, say, 2/5. And we'll take, let's say, 1/3 of that. Okay. What's the procedure? 2 times 1 is 2. 5 times 3 is 15. Okay. Graphically, what's happening? I start with fifths. I shade 2 of them because I have 2/5. Then I take 1/3 of that. I need to separate this into thirds. Look at that. And I have 1 of these thirds. Here's a third, this whole column. Here's another third. Here's another third. I just want one of these columns. So I end up with 2. You can see 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2/15. Right? I take 2/5 and then I take 1/3 of that section, of that 2/5 section. Right? So there's a couple of ways to look at it, right? I want you to understand what is happening graphically or physically, and I want you to understand what's happening just in terms of pure calculation, right? If you think about what's half of a half, right? Oh, let's do that. That's something that we might see in a recipe or in doing some carpentry work or something. I have half of a half. What do I get? I get 1/4, right? Multiplying straight across, 1. Multiplying straight across, 4. What does it look like? I'll do a circle this time. I start with half And then I cut that in half, leaving me with a fourth. Right? This section here, fourth of a pizza or whatever. Right? Good. You can do it. Right. Okay. When you're dealing with fractions, you might want to use some physical examples like cooking and measurements, right? That will really help. But also, I like to draw pictures in addition to, of course, being able to deal with the numbers. Now, so that's multiplying. If you have any questions, you can always write to me. I love questions. My email is noodle McDoodle, this is an E, at yahoo.com. And of course, like on all my videos, you can stop them, you can watch them again, you can try to follow along with your pencil on your paper and actually do the work along with me. That's the best way. That's the best way. Okay, let's look at dividing fractions, right? When we're multiplying, we know that we're building things up. So 3 times 4 equals 12. But this is reversible. What do I mean by that? I mean that if I start with 12 divided by 4, I'm going to get 3. See? Multiplying means building it up. Dividing means breaking it down. Right? So let's look at what happens with fractions that way. Let's say we have 2/5 times, divide 2/5 divided by 1/7, right? What do we do? Okay, here's the procedure. It's called keep, flip, and keep, change, flip. We keep this one the same, keep, so I'll rewrite 2/5. We change the division symbol into a multiply symbol. I like using a little star for my multiply. You might also see an X or a dot. And then we flip. That means I flip this second fraction upside down. Can you see what's happening there? Good. Once we do that, then it's multiply straight across. 2 times 7 is 14. 5 times 1 is 5. Let's change this to a proper mixed number. It's called an improper fraction. Now, how many times can 5 go into 14? 2 would make 10, and then I have 4/5. There we go. Same thing. Right? So we keep the first number, we change the division to multiplication, and we flip the second one. This is called a reciprocal. A reciprocal is when we take a fraction and we invert it. Right? Good. I'll do another example. Should be getting the hang of it. Let's try it. Let's say we have 3/4 divided by 1/3. I keep, I change, I flip. 3 times 3 is 9. 1 times 4 is 4. That's improper. How many times can 4 go into 9? 2 with 1 left over. Right? That's the procedure. I don't like improper fractions. Sometimes they're useful. But let me show you what this really looks like graphically. If I start with 3/4, that would look like this. Can you see it? There's a little glare here on the light. There we go. Better. 3/4. Okay. I want to separate this into thirds. Okay, I could do that. How many of these thirds do I want? I want one of them. How many thirds do I have? That's the question. I divided it into thirds. How many of those thirds do I have? Okay. This whole column here is a third, right? This whole column is a third. But it's not full. So I want to fill it. So I'm just going to move this block over here to fill it. Now I have a third. And then I'm going to fill this block here. I'm going to fill it. Now I have a third. I have a third here. I have a third here. And then I have a fourth of a third here. So how many thirds do I have? I have 1, 2, and a fourth. 2 and a fourth thirds, right? So I took 3/4, I divided it into thirds, and I'm left with 2 and a fourth, or 9/4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, a little tricky, a little tricky. You can do it. I'll just do one more example where I show you the process, the procedure for dividing fractions. The keep, flip, keep, change, flip. Suppose we have 3/8 divided by 1/2. All right, I keep, change this to a multiply, flip. Now, when I multiply across, 3 times 2 is 6, 1 times 8 is 8. And I could reduce that, divide both sides, top and bottom, and I get 3/4. That's interesting. Let's look at it graphically just for fun. First of all, I want to start with eighths. Okay. How many eighths do I have? I've got 3 of them. Okay. Now I say, I want to divide this into halves, right? Well, look, I'm going to divide this whole thing in half, right? 3/8 divided into half. How many halves do I have when I have 3/8? Well, I haven't even got one complete half here. I've only got, can you see it? There it is. 3/4 of a half, right? 3/4 of a half. So, if I reverse this whole equation, I would get 3/4 times 1/2. And when you do that, 3 times 1 is 3. 4 times 2 is 8. 3/8. See? So I'm saying 3/4 of this half, this whole part here is a half, is equal to 3/8. Right? Or going backwards, 3/8 divided into halves is equal to 3/4. All right. Got to practice with this stuff. It's not easy. I know you can do it. Okay, if you have any questions, just write to me, noodlemcdoodle@yahoo.com, or you can put it here on the Growing Spirit online school page. All right, I hope everybody's doing great out there. Take care of yourselves, and talk to you soon.